Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, you learn about AWS services. You know that we have started a series about AWS Glue Job optimization, and this is the part 4 of that series. So let's get started. Before you start on the topic, it is important to understand that optimization of a glue job is a pretty advanced topic. That means unless you understand the fundamentals of AWS Glue and Glue Job and how to use PySpark to build the glue job, you will not able to make sense of the tutorial. So if you already know about AWS Glue and how to build a job inside Glue, then you're good to go. You can move ahead. If not, I'm providing 2 of my tutorials, a link in the description box, and you can actually follow those tutorials to get some of the fundamental understanding about AWS Glue Job. And then you can, of course, start on this tutorial. I will also recommend to go through AWS Glue Job Optimization Part 1 video, at least for first 6 minutes, because that will give you some good idea about how I am organizing this tutorial, because you might say, hey, you might find that I'm starting it at random, but that's not the case. If you go through the part 1, then you might able to connect what I'm talking about here. So these are the few things I will recommend you do to get a maximum out of this tutorial. So let's move next. So what is today's technique? And today's technique is using AWS Glue Spark Shuffle Manager. So we are going to use AWS Glue Spark Shuffle Manager to actually use S3 as the location for both spill data and shuffle data. So when you run the glue job, actually your glue workers create a lot of spill data and shuffle data. And what we are going to learn, how you can use S3 as a location for that kind of data. And this configuration actually helps improve job resiliency, job reliability in Glue. So that's the technique we are going to learn today in the part 4 of the tutorial. So before we do that, let's try to understand some of the fundamentals of Glue job capacity configuration, and we also learn how exactly Glue job works, because then you can understand this the problem statement much better. So first, understand how do you configure Glue job capacity. So in order to configure Glue job capacity, you define first number of workers, how many workers you want to use for the Glue job, and then you define a worker type. And in worker type, actually you can define 3 types of worker, but here I'm covering only G.1x and G.2x workers. But you can actually go for standard G.1x and G.2x. But I'm trying to talk about some new generations here. So when you define the worker type, one worker type you can select is G.1x, and when you go for G.1x, basically you're going for 1 DPU capacity, and 1 DPU capacity will have basically 4 vCPUs, 16 GB RAM, and 64 GB of disk. Or you can also go for G.2x worker type, and when you go for G.2x worker type, then you get 2 DPUs, and 2 DPUs are equivalent to 8 vCPUs, 32 GB memory, and 128 GB disk. So in a very simplistic term, in Glue job, when you're defining Glue job capacity, you define number of workers you want to use to run the Glue job, and also worker type as either G.1x and G.2x, and based on that, number of DPUs gets allocated to your Glue job, and based on DPU being allocated to Glue job gets certain vCPUs, memory, and disk space to complete the Glue job. That's how you define capacity of the Glue job. Now, keep this information in mind, because now we are going to go a little deeper. So once we have defined this number of workers and worker type, how does parallel data processing happens for the Glue job? Because Glue job behind the scene uses Apache Spark, And Apache Spark does parallel in-memory data processing. So now we are going to understand that if I allocate a worker type and number of workers, how does that help in parallel data processing? So the way it helps in parallel data processing is that, first of all, depending on how many number of workers you have configured for the glue job, those many workers actually start. Okay, and for each of these workers, in each of these workers, a number of executors run. These executors are responsible for processing your data in parallel. So you can see here we have number of workers in parallel, and then in each of these workers we have a number of executor. Now number of executor within a worker depends on number of vCPUs the worker has. So number of vCPUs basically decide number of executors running within a worker. So each of these executor will have certain memory and certain CPU allocated to them. And then these executor will do processing of your data in parallel. So you can see here, if I have got 3 workers, then I've got 3 workers in parallel, and then each of these 3 workers will have their own parallel executors, and each of these individual executors with certain memory and certain CPU capacity will process a part of your data. And that's how parallel processing works inside Glue Job. Now, each of these executors also need some disk space which they can use for storing their data. So for instance, if an executor is trying to perform transformation on some data and it wants to store spill data somewhere, then that spill data is stored in the disk. Or if you want to do any kind of shuffling of the data, and I'm going to cover these 2 things in more detail in the next 2 slides, then you need disk space. But for you, it's very important to understand that each of these executor basically have 3 resources allocated to them. They have certain CPU for compute, certain memory, and they also have certain disk space which they use to store the data. And that's how each executor unit runs in parallel with their resources to perform parallel processing for your data in Glue Job. Now, as I mentioned earlier, that when these executors are performing the transformation, and when they're doing very large amount of data transformation, like I'm talking about like very big data they are trying to transform, and of course they are doing in parallel. So each one has got as a part of parallel processing, got a part of data to process. But even if you're trying to process a very large amount of data, even this part of data for this executor is quite a big data for itself. So what this executor does, this executor actually stores the spill data which is created as a part of the transformation to this local disk space allocated to it. So each of these executors within the workers store their spill data into this disk space. Similarly, a lot of data shuffling also happens. So since each of these executors are processing their part of data, but sometime when you run operation like I want to join, or if I want to do a group by or reduce by or repartition, so whenever any of these kind of transformation is run, executor has to make use of data available in some other executor to join it together. That means 2 executor has to put their data together in order to perform group by or join operation, and that's where data shuffling happens. So basically, as an example, if suppose this is one executor which is this is one executor which has to shuffle the data. What it will do, it will simply write its data to the local disk allocated to it, and then over the network, this data is then passed to the other executor, so that other executor can perform join operation or group by operation. So keep this in mind that whenever you run this kind of transformation like join or group by, a lot of data shuffling happens, and for data shuffling to work, these executors will actually basically store their data, or these workers will store their data to the local disk, and then this data is sent over network to the other worker, other executor, to perform the join, group by, or reduce by transformations. So a lot of shuffling of data happens through this disk as well. So having understand how this shuffling and spilling happens and how these executors make use of their local disk space, let's run to what is the problem statement. And the problem statement is these disk sizes are small. So each of workers has got their own disk size allocated based on the worker type you have selected, and then each of the executor is using a part of that disk for its own processing of the data. So these disk spaces are limited, and if you're trying to process a very large amount of data, sometime you will hit the limit of the disk space. So sometime it might happen that you're trying to write a spill data, or you're trying to write a shuffle data, but you cannot because disk does not have enough space for you. And in that case, Spark throws an error saying no space available on the device, or something like metadata fetch failed is exception. So such error is thrown by Spark in Glue Job when there is no enough disk space left for the executor in order to spill or shuffle the data. And this is the problem we are going to solve today in today's optimization video. So when you come across a scenario that you're trying to run a transformation, but that transformation is not able to run because the data is very large, and the kind of spill data or shuffle data is creating is there's not enough disk space for that. In that case, you get an error like no space left. So how do we solve this problem? In order to solve this problem, we can use a feature called AWS Glue Spark Shuffle Manager. And the way Spark Shuffle Manager works, it says that you don't use your local disk for your shuffling of your data or for any kind of spill data. Don't use local disk. Rather, you use S3 bucket. And if you're using S3 bucket, since S3 bucket is highly reliable, is scalable, unlimited capacity, you will never reach a situation where your disk is full. So basically, the simple solution Spark Shuffle Manager provides is that it tells executor not to use their local disk for the shuffling purposes, for the spill data purposes, but simply use Amazon S3 bucket for that purpose. So for instance, if shuffle has to happen, the way it works is that one worker or executor will simply write data to the S3 bucket. It will not write to local disk, but write data to the S3 bucket, whether it is for spill or shuffle. And then the other worker will simply pick data from the S3 bucket, if it is the case of the shuffle, by the way. So simple solution. Shuffle Manager saying that don't use your local disk, but use an S3 bucket for spill data and shuffle data storage. And that way, since S3 has a limitless capacity and it is reliable, you get a better resilience for your job, where no matter how big data you're processing, you will never end in a situation where your disk space is full, because you're not using any disk here, but you're using Amazon S3 bucket. So how do we configure that? And that's the beautiful part. Though we are asking your Spark executor to not to use disk but S3 bucket, but if you want to configure your Glue job for that, it's pretty straightforward. all you have to do is simply set up these 3 parameters as a job parameter. So first one you configure setup is called write shuffle file to S3 equal to true. If you put this job parameter in your glue job, then it tells job that, hey, if you create any kind of shuffle files, don't use disk space, but use S3 for the storage. The second one is write shuffle spills to S3 equal to true. If you put this one, that means telling glue job that if you create any spill data, don't use local disk, but write to the S3 bucket. And you can also provide configuration where you're simply saying that my S3 shuffle bucket location is this particular bucket and this folder, or it could be only bucket as well. So you simply provide the location of your shuffle bucket, and voila, that's it. And all it will, your glue job will start using S3 as the shuffle location, as a spill data location, rather than using the local disk. And you will never see this kind of error where your disk is running out due to large amount of data transformation. So that's pretty much how it works. Now, few considerations which is very important when you are using Shuffle Manager with S3. The first one is that Shuffle Manager currently supports only AWS Glue version 2.0 and Spark 2.4.3. So you know that Glue version 3.0 has come, but if you want to use the Shuffle Manager, currently it's supported with 2.0 and 2.4.3. To be honest, I have not tested with 3.0, so I'm not sure it works with that or not. But if you look at the official AWS documentation, it says that Shuffle Manager works with 2.0, Glue 2.0 and Spark 2.4.3 only. Your Shuffle bucket location, your job location, both should be in the same region. So yeah, same region for both job and Shuffle bucket. And the third one, when you create a Shuffle bucket for your Glue job and you're doing a large transformation, that means you're spilling a large amount of data into, or shuffling large amount of your data into your S3 bucket. That data is not cleaned up once job is done. So one might have expectation that, hey, once job completes, my data would automatically clean up from those locations. That's not the case. So you might end up in a scenario where your Shuffle bucket location is growing and ever growing for you because there's no cleanup job happening in that location. So for that purpose, it is important that you define some kind of storage lifecycle policy where you might want to clean up your objects which are more than 2 days, 3 days old, depending on how long your job run, actually, or more than 1 week old. And that way you can keep your Shuffle location optimized, size optimized, and you're not paying for ever increasing data getting stored at that location. So these are the few things for you to understand or consider when you are configuring your Shuffle location, S3 as a Shuffle location using Shuffle Manager. Time for a demo. It's pretty straightforward demo. I'm going to do that. I have got two data in S3 bucket, customers.csv and then sales.csv. Them I have cataloged into DB in Glue, customers and sales. Then I'm going to use a Glue job to do a join between these two data sets. So they have customer ID as a common column. So I'm going to join, run the join operation. And by running the join operation, actually, I am pushing it to do a shuffling of the data. And then I'm simply going to configure S3 as a location for the join data, and I'm going to write the output transformation also to the S3 bucket. So that's a demo I am going to do today. So let's jump to the AWS console. So here in AWS console, I have got my bucket called Dojo My Data, which has got 4 folders. So I have got a customers folder where I've got my customers data. I've got sales folder where I've got my sales data. I've got output folder where I will keep my transformed output data. And I've got shuffle folder, which I'm keeping to store my shuffle data. Now, if I go to my customers folder, I can see my customers.csv file. If I go to my sales folder, I can see my sales.csv file. If I go to my output folder, refresh it, I see it's blank. It's supposed to be blank because I have not written the job yet. And if I go to my shuffle bucket location, and if I refresh it, again, it is blank because I have not used my job yet. If I go to my Glue console, you can see that I have got my database DojoDB. Under DojoDB, I have got two tables: customers and sales. Okay. So yeah, I've got my customers and sales table. And then if I open my customers table, you can see my columns, and this is the customer ID on which I want to make my join. If I go to my sales table, and I've got some data, and then I've got a customer ID again on which I want to make my join. Again, it comes from some dummy data. All I want to do is create some join operation. So I go to my Glue console, and then there I want to create a Glue job. So let's create a Glue job. I use a visual blank canvas, create it, and then I go for my source. I want to read from my Glue data catalog. Let me reduce a bit here my resolution. Okay, better. So I go to my source data catalog here and say I want to read from my DojoDB, and I want to read from my customers table. So I've got my output schema here populated. Fair enough. Let me close this span here, so I got more space. Then I read from source again. So I click on the source again, and this time, so this one is reading from my DojoDB customers table, and this one I want to read from my DojoDB sales table. So I have got my both data available, read from through different nodes. Now what I'm going to do is that I'm going to perform some select transform. So I come over here and say I want to do some select transform here. Okay, where is that select field? And I just want my customer, for my customers table, all I want, this is customers table, right? Yeah, sorry, yeah, this is my customers table. So my customers tables, all I want is customer ID, customer name, nothing more than that. Similarly, I perform some select operations on this one as well, my sales table as well. So I simply want to say I want to do a select transform here, and from here all I want is a customer ID and total sales, nothing more than that. Okay, these two, yeah, customer ID and total sales, and from here I'm getting customer ID and customer name. So after that, I then go to this join transform here. So I put on join transform. You can see here, I've got my join transform here. If I go to my node properties, I can select both here. There we go. So I've got a join transform here, and this join transform is reading, joining data output of, or data frame output of these two select transforms. If I go to transform here, okay, and say, okay, how do I want to join? So I want to add a condition, and the way I want to join is my customer ID in customer table and my customer ID in sales table, both joined together. So there we go. So I have got my join done. Now I need to simply write the output file. So for that I click on target to S3, and here I am simply saying let's write in Parquet format, snappy, and my location is my location is my data output choose. Pretty much, okay. So so that's how that's how my configuration look like. If I can, okay, I can minimize this. So basically what I'm doing here is I'm saying that Okay, or if I can make this one bigger. So I'm saying read from my customers table, read from my sales table, then do some select filter on customers, select filter on sales table, and then, what I'm saying is that join both table based on customer ID. So this join will force the shuffle operation, and then I simply write that to an S3 output location. Yeah, that's it. So let me configure some job details. So I go to job detail and I call it, this is my dojo job. My IAM role is dojo glue job role. I come down. Okay, now first consideration, I have to use glue job 2. So I have to use glue job version 2. Okay, that's very important. Glue, because Shuffle Manager works with glue job version 2 only. So I click on glue 2.0 Spark 2.4. Fair enough. Then I come down. I want to disable bookmark because I have already tested once. But not necessarily that you have to disable. I'm disabling this time because last time I tried to run, it somehow kept some metadata about my glue job, and it didn't process the data. So I'm intentionally making it disable, but not that you have to make it disable. Okay. Number of retries to 0. 0. I want it to fail fast for me for demo. But in actual production, you want to keep number of retries to a higher number because you want to make sure your job finishes. And then I go to my advanced topics. So few things what I've done, just I gave my name. I selected my IAM role. Then I glue job location, glue job version as 2.0. And then I make job bookmark disable, but it's not necessary. Actually, in fact, let me enable it. I don't want to give a wrong impression. Yeah, so job bookmark enabled, and number of retries is 0. Fair enough. Then I come to advanced because I need to set the job properties. So if I come all the way down here, I can set my job properties here. So now first job property I need to set is if I bring this documentation here, is write job shuffle file to S3. This one is true. Second property I want to add is write shuffle spill to S3 is also true. And then third job property I want to do is configuration. My spill shuffle data location is, I'm providing my shuffle data location over here. So here we go. To my S3, my dojo, my data, shuffle. Okay. And I simply save it. So that's a pretty much my configuration is ready. In fact, so you can see here my configuration was straightforward. I simply provided the job name, job role, make sure that glue version is 2.0, and then I come all the way down here and I provided my job parameters. With this, I am all set. If I run this job, it should use S3 as the shuffle location. And it will use it because I'm using a join operation here, and join will force it to do the shuffle. So let me run this job. So here I've started the job, and I'm going to wait till this job finishes. And when it finishes, I will show you the output, and I will also show you the data written at the shuffle location. So let's wait till this job finishes. Okay, so it has finished the job. You can see job status is successful now. It took roughly 1 minute 16 seconds. Now if I go to my Yeah, here I go to my output. So you can see here my output is created. My transformation has worked and it has written a Parquet file output in my Dojo my data output location. Now, so this is as expected. Now, if I go to my shuffle bucket and I refresh it, I see data created here as well. So you can see it using a Spark application. If I go inside that, it creates some shuffle bucket, and you can see the shuffle data. So you can open up this data and you can see more in detail, but just wanted to show you that some data has been written in the shuffle location as well, because this job has not used its local disk for shuffling the data, but it has used S3 as a location for shuffling the data. So that's pretty much for the video today, guys. I showed you how you can configure S3 as the location for your shuffle data or spill data for your Glue job, which can really help you build a very resilient and reliable Glue job, which can do a large amount of data processing without running the risk of disk going out of space. So hope you like the video, and if you like the video, please click on the like button. Please subscribe to my channel. I always look forward to your feedback, your comments, whether it is for a new content or if you want to discuss something from the architectural design point of view, or if you want to correct me for some of my mistakes. Please feel free to reach out to me for any of those things in my comment section. I look forward to your feedback. I promise to come back again in a week's time with another such video. In the meantime, please stay safe and have a nice day. Bye-bye.